Hello everyone, Nicole here again as your Gen Math teacher of the day. Today we'll be talking about rational equations. So now who can tell me what a rational equation is? So a rational equation is an equation containing at least one rational expression with a polynomial in the numerator and denominator. It can be used to solve a variety of problems that involve rates, times, and work. Moving on to the steps in solving these equations, your first thought should be to simplify and eliminate all fractions. Here are a couple of examples. First, let's consider the rational equation 5 over 8 minus 3 over 5 equals x over 10. We'll be solving to find x. To add and subtract fractions, we know to find the least common denominator or LCD, which is 40. Multiply both sides of the equation with the found LCD. 40 times 5 over 8 minus 3 over 5 equals x over 10 times 40. Simplify the fractions. 25 minus 24 equals 4x. This makes 1 equals 4x. Divide both sides of the equation by the coefficient of x, which is 4. 1 over 4 equals 4x over 4. Now you have the possible values of x. X equals 1 over 4. For our second example, let's consider the rational equation 1 over x is equals to 2 over 3x minus 1. First, we'll transpose both sides of the equation to equal 0. 1 over x is equals to 2 over 3x minus 1 equals 0. Similar to our last example, of course, we find the least common denominator for our fractions, which is x times 3x minus 1. Now we multiply both sides of the equation by the LCD we found. 3x minus 1 minus 2x over x times 3x minus 1 equals 0. We combine the similar terms, apply the distributive property, and simplify our fractions. X minus 1 over x times 3x minus 1 equals 0 equals x negative 1 equals 0. Now you have the possible values of x. X minus 1 equals 0, meaning x is equals to 1. Moving on, let's have an example using cross multiplication. Consider the equation 2 over x plus 1 equals 4 over x minus 3. Now our first step, as always, is to eliminate our fractions. We do that here by cross multiplying the two sides. 2 times x minus 3 equals 4 times x plus 1. From our new equation, we can simplify. 2x minus 6 equals 4x plus 4. Next step, apply the properties of equality and the subtraction property of equality. 2x minus 6 equals 4x plus 4. 4x over 2x minus 4x minus 6 equals 4. Now we apply the addition property and equality. 2x minus 4x minus 6 equals 4. 6 over 2x minus 4x equals 4 plus 6. Combine the similar terms. 2x negative 4x equals 4 plus 6 equals negative 2x equals 10. Using the division property of equality, we'll divide both sides by the coefficient of x negative 2. Negative 2x over negative 2x equals 10 over 2. Now we have our value of x. X is equals to 15. Still following? Let's move on. We have about 2 more examples left to learn. Let's look at the next rational equation. X minus 4 over negative 2 minus 4x plus 5 over 2x plus 3 equals 0. Like the rest, to solve fractions, we find the least common denominator. For this example, it's negative 2 times 2x plus 3. Next, that's right, we multiply both sides of the equation by the found LCD. Negative 2 times 2x plus 3 times x minus 4 over negative 2 minus 4x plus 5 over 2x plus 3 equals 0 time is negative 2 times 2x plus 3 to 2x plus 3 times x minus 4 minus negative 2 times 4x plus 5 equals 0. Apply the distributive property and simplify. 2x squared minus 8x plus 3x minus 12 minus times negative 8 minus 10 equals 0 to 2x squared 8x plus 3x minus 12 plus 8x plus 10 equals 0. Likewise, combine the similar terms. 2x squared plus 3x minus 2 equals 0. Because we now have a quadratic equation, use factoring or the quadratic equation to find the values of x. We will be using factoring for this equation. Times 2x negative 1 times x plus 2 equals 0. And now you can find all the possible values of x. X is equals to negative 2 and x is equals to 1/2. Now for our final example for today. Consider the equation x minus 3x2 minus 25 plus 1x plus 5 equals 1 times x minus 5. You guessed it, our first step is find the least common denominator. X plus 5 times x minus 5. Now multiply both sides by our LCD. X plus 5 times x minus 5. X minus 3x2 minus 35 plus 1x plus 5 equals 1 times x minus 5. Apply the distributive property. X minus 3 plus 1 times x minus 5. X minus 3 plus 1 minus 5 equals x plus 5. Now simplify. 2x minus 8 equals x plus 5. 2x minus x equals 8 plus 5x equals 13. Now you have our value of x. X is equals to 13. Steps involved in graphing rational functions. Number 1. Find the asymptotes of the rational function if any. Number 2. Draw the asymptotes as dotted lines. Number 3. Find the x-intercept and y-intercept of the rational function if any. Number 4. Find the values of y for several different values of x. Number 5. Plot the points and draw a smooth curve to connect the points. Make sure that the graph does not cross the vertical asymptotes. Example. Graph the rational function. Y equals 4x plus 12x plus 1y equals 4x plus 12x plus 1. This vertical asymptote of a rational function is x, value where the denominator of the function is 0. Equate the denominator to 0 and find the value of x. 2x plus 1 equals 0x equals negative 12. 2x plus 1 equals 0x equals negative 12. The vertical asymptote of the rational function is x equals negative 0.5x equals negative 0.5. This function has the x-intercept at negative 4, 0, and y-intercept at 0, 1. Find more points in the function and graph the function. Sometimes the given rational function has to be simplified before graphing it. In that case, if there are any excluded values where the function is not defined, other than at asymptotes, then there is additional step involved in graphing in the function. To represent the undefined function, make sure that the function is not continuous, smooth curve at the excluded value. This excluded value is usually referred to as hole in the rational function. For example, the rational function y equals 4x squared plus x2 plus xy equals 4x2 plus x2 plus x has a hole at x equals 0, x equals 0. Please note that the graphs of the rational function satisfy the vertical line test. Process for graphing a rational function. Number 1. Find the intercepts if there are any. Remember that the y-intercept is given by 0f of 0, 0f of 0, And we find the x-intercepts by setting the numerator equal to 0 and solving. Number 2. Find the horizontal asymptote, if it exists, using the fact above. The vertical asymptotes will divide the number line into regions. In each region, graph at least one point in each region. This point will tell us whether the graph will be above or below the horizontal asymptote, and if we need to, we should get several points to determine the general shape of the graph. Number 4. Sketch the graph. Let's take a look at a couple of examples. Example number 1. Sketch the graph of the following function. F of x equals 9 over x squared minus 9. Okay, we'll start with the intercepts. The y-intercept is f of 0 equals 9 over negative 9 equals negative 1. So 0 and negative 1. Since the numerator is a constant, and so there won't be any x-intercepts since the function can never be 0. Next, we'll have vertical asymptotes. At x squared minus 9 equals 0, x equals plus 3, so our values are x lesser than negative 3 lesser than x, and 3 greater than x, and x greater than 3. Plot the values according to this region and sketch your graph. So the first step for graphing is to find the intercepts if there are any. The y-intercept is for this function is 0 and negative 6, and the x-intercepts are negative 2 and 0. Now we need to determine the asymptotes. Let's first find the vertical, which is x equals 1, meaning our values can either be 1 greater than x and x greater than 1. Now the largest exponent in the numerator and denominator is 1, and so by the fact that there will be a horizontal asymptote at the line y equals 3 over 1 equals 3. Now we just need points in each region of x's. That means that we'll just need to pick values of x for our graph. For example, substitute x with 2 f of x equals 3, 2 plus 6 over 2 minus 1 equals 12 over 1, meaning our coordinates are 2 and 12. Continue plotting with your values and you'll have coordinates to your graph. That is all for today. Once again, this is Teacher Nicole, your Gen Math teacher for the day, signing out.